Alright, this is Matt Salvino, and I'm going to be demoing the Lab 10 student project. For my project, I used a DHT11 temperature and humidity sensor, and I added a 10K resistor that it required for it to be executed. And there's three prongs for the temperature sensor. The left one is the VCC power supply that is connected to the pin 1 for the Raspberry Pi. The far right one is the ground that I connect to the pin number 6, and then for pin 7 that is the middle one, which is the data. So whatever the temperature and humidity data is, that will be brought into the Raspberry Pi. So let's see the code executed. So as you can see, I did that for the user, the title, and how to exit it. And you can see that the temperature is just exited from Control C. So I did add a few features that I'll show in the code, and I did add Celsius and Fahrenheit depending on who's reading this. Some may be more familiar with Celsius, or some may be more familiar with Fahrenheit, as well as I added a clothing attire that, depending on how hot or cold the room or area is that somebody's executing this, it allows one to understand what they should be wearing in that certain area. So now let's go to the code. And also, before I go to the code, I'll show how I execute the program multiple times in order for the user to be updated to what the temperature is. Alright, so I did some research for this temperature sensor, and I did find some code that was helpful for me, and as well as using that, I did add some other features that I'll show. So you can see I use a number of libraries. One of them that is familiar is the Wiring Pi that we did use for Lab 9. And if you can see with this code, it kind of has a similarity to the Lab 9. I did use the output and input is the temperature, and when the output comes from the DHT11 sensor, and when the DHT11 pin is high, then the code is not the code, but the temperature sensor is on, and all the data that the temperature senses from both the temperature and the humidity will then be executed with the pin mode DHT11 pin input. So a number of these statements below do execute break statements if these statements are true. And down here, this if statement allows each bit to go into the storage bytes, and once each part of the array adds up to the array, the total array, which is named DHT11 underscore val4, then the program prints out the temperature. So one of the features I did add was I added the conversion from Celsius to Fahrenheit, which is the 9 divided by 5 times the Celsius plus 32. And another feature I did add was, from earlier you saw the clothing attire. Well, what I did was I assigned a new variable, clothing, to the Fahrenheit temperature, and depending on the temperature ranging from the clothing being, or the temperature being above 90 all the way to lower than 50. These if and else if statements print out what a clothing to wear. Now, in this function, this is where the program is able to execute multiple times, and while this program is true, then the function will be executed multiple times. And this delay, I know the delay is in milliseconds, and when you saw the program executed, it did seem faster. Well, that's because the else above is executed multiple times, and that may show that may make the gap between the outputs seem longer than 100 milliseconds. And because there's nothing outputted for the else, it's just returned 0, then nothing will be projected onto the screen, but that's where that gap is from when you are shown the outputs. And that's my code, and that is my temperature sensor student project. Thank you.